Oh, welcome guys. So in this video, I'm trying to prove this Brahmagupta's formula. Okay, I think this is an Indian guy, right? So the idea is that if you have a quadrilateral and which is inscribed by a circle, right? Or basically inscribe a circle. Just like a figure that is ABCD and the PQRS are basically the sides of length. Okay. Right. So the idea is that we want to prove. So this formula tell you about the area of this. So the area of this guy, this red guy. Okay, and the formula basically is that suppose I can calculate the sum of all lengths. Sum of PQRS and divided by 2, and the area will be square root s tilde minus a, s tilde minus p, s tilde minus q, s tilde minus r, s tilde minus s, and take a total square root. Okay, and if you let the one length to be 0, then you will reproduce the so-called very famous Heron's formula of triangle. Although this formula is not so famous as the Heron's formula. Okay, and let's see a proof. Because the proof is somewhat lengthy, so I write down all the details. So let's read one by one, one line by one line. So let's see the proof. So let's see the area is called K. Okay, so by definition, this area is a half P. If I draw a BD, right? I draw a line, then area will be half PQ sine A plus a half R sine A, sine C, right? But the sine C is pi minus A, so it's sine A, because these are a circle. Okay, and this kind of circle, which can be put, this kind of quadrilateral, which can put in the circle, are called a cyclic quadrilateral. So this is like just some terminology which seldom be used. Okay, so k squared will be 1 to 4 pq plus r squared sine a squared. So that's times 4. So 4k squared will be. Sorry, I should be. Let's close. Yeah, 4k squared will be pq plus r squared 1 minus cosine squared. And then we have this BD, right? We have cosine law, so BD is p squared plus q squared minus b cosine a equals to r squared plus s squared minus plus 2rs cosine a. So we got cosine a equals to p squared plus q squared minus r squared minus s squared 2 times pqrs. And then we put this 1 minus cosine a, right? So this turns fixed, and 1 minus, right? So it becomes 4 pqr plus r squared minus p squared plus q squared minus r squared minus s squared squared. And this is 4 and pqr squared. Okay, so let's see the final proof. So the proof is very easy. So this line, right? This line, these two guys can cancel, right? So and I divide it by 4. So the denominator will be 16, and the numerator will be this guy, right? So you see this guy is the a squared. So we get a squared minus b squared is just a minus b plus a minus b times a plus b. So a in this case is that 2pq plus rs is a, while the b is that p squared plus q squared plus r squared minus r squared minus a squared. So we get a minus b, a plus b, right? So we get this term and this term. Okay, and you combine this the same as you combine this 2pq and the p squared, and the r term with r squared, s squared, and then pq, p squared, r s squared. So we got these two factors, and then we use the same formula again, and we get a half 2, 2, 2, 2. And then you see this is r plus s minus p plus q, r plus s plus p minus q, right? So you get the 4 terms. And then you will see there are both 3 positive and 1 minus in 1 negative term in these 4 in these 4 terms. So let's say s tilde will be p plus q plus r plus s divided by 2 is basically the half parameters. Then finally you get is our k will be s tilde minus q, s plus t r minus p minus q. This is minus r, this is minus s. Okay, so this is the answer. Okay, and the remark is that suppose you that let's say that's s squared to be 0, then you get the Heron's formula. Okay, And if you have not yet seen the Heron's formula proof, then you can go back to my YouTube channel, and you can go to my YouTube channel or go to my playlist of planar geometry and type the Heron's formula, and then there will be exact detailed proof of how to prove it. Okay, I think it's good for today. Thanks for you guys watching. Be sure to subscribe to my channel. Thanks.